lesson 1.8. Our title today is proportions, and our learning goal is pretty short. I can solve proportions. Okay. First of all, we got to know what a proportion is. What is a proportion? We're going to fill in the blank here, and it will tell us. A statement that two ratios are equal. So we already know what a ratio is. A ratio is a comparison of one number to another, typically written as a fraction. It can be written other ways. When we have them as a proportion, we are going to write them as fractions. We're going to have a numerator and a denominator, our two numbers that are being compared. But we're going to have two ratios set equal to each other. So a proportion is actually an equation that has a ratio on one side and a ratio on the other side. Okay, so we're going to learn how can we solve them, and we're going to use something called the cross products property. So when have you solved proportions before? Do you think you've done this back in 7th grade or 8th grade? Does this sound familiar? Cross products and proportions. So anybody think they know if we have A over B equal to C over D, does anybody think they know what the cross products property would allow us to do? Cody?
Does it mean you can cross multiply and cross divide?
Okay, I like the fact that we're still just going to multiply. Products, cross products means we're going to multiply, right? We're not going to do any dividing in our cross products. We're going to end up doing some dividing when we're solving. But cross products means, and you said cross multiply, what does that mean? Like, can you be a little bit more specific?
You would multiply A by D and C by D.
Okay, yeah. So we're going to take, if you take the numerator of one of them, we're going to start with A, and you multiply it not by its own denominator, but by the denominator of the other ratio, you should get the same result as if you multiply the other numerator times the remaining denominator. Oops, yeah, that's not the one I want. After it got messed up there, it threw me off. C times B. Okay, what do you do to my board here, Mr. Okay. A times D equals C times B. Now, in multiplication, order does not matter. So it could just as easily be, if we wanted to, we could say that we're going to take D times A, and that would be the same as B times C. Order does not matter in multiplication, but what matters is when you're setting up your cross products, you have to set those up properly. You have to take the numerator of one ratio times the denominator of the other ratio, and then set that equal to the other numerator multiplied by that leftover denominator. It has to be done. We have to have our cross product set up properly, but then we can decide who's going to be first, the numerator or the denominator in the multiplication. Okay? So let's start solving these. And I do want you, hear me on this, I do want you to show the steps I'm going to do with you today in the notes, because they're going to get more complicated than these. And if you're going to do it the way you did back probably in elementary school or in junior high, then when we end up introducing numerators or denominators that have more terms to them, you're going to get messed up. So let's just kind of start with a good process right away to begin with. Okay, anybody think they know a cross product we can set up for number 1? Noah?
5 times 8.
5 times 8. So we're going to show that. That product should be the same as what other product?
2 times whatever.
2 times whatever number is there, and it's called what?
X.
X. So we'll just leave it X. Okay? So we need to show that step. That's what we call our cross product step. And then we're actually going to find those products. So, Aurora, what's 5 times 8? 40. Okay. Calvin, what's 2 times X?
2x.
2X. Julia, what are we going to do to both sides of this equation to get that X alone? Divide by 2. And when we're all done, we're going to say 40 divided by 2 is what, Devontae?
20.
20. So 20 equals X, there's our solution. The missing number in our proportion is 20. Okay, anybody think they know how we could do even if it's a mental math check, we could check to see if we have a good answer. Okay. Does it seem reasonable to get 20, first of all? Can you give me a reason why it seems reasonable without having to do any calculating, really? What makes you feel like we have a reasonable answer right now? Julia?
Because we got 20 for x, and if you take 2 times 20, you get 40, which is the same as 5 times 8.
Okay, so you're putting it back in and it's checking out in our cross product saying you get 40 equals 40, okay. Cody?
Well, I do what I used to do is to do check these on. What we did is we multiply 2 times the 5 and you get 10, and then you divide the 2 by the 8 and you get 40, and then you gives you your answer. Because 10 times 4 is 40.
Okay, sure. Run that by me again, Cody.
Should I just show you what I mean?
Sure, absolutely. Come on up and show me because I would like to know what you were taught and why it works.
What we did is we multiply the 2 by the 5 and get 10. And then we divide this by 8 and you get 4.
Or do you mean 8 divided by 2 and get 4?
8 divided by 2.
Okay.
And then you get x is 4.
Okay.
And then you would multiply those together to get 40.
Okay, so you're saying the solution to this then is 4 or 40?
It's 40.
It's
because when you
40.
multiply 10 by 4, you get 40 grams.
Do you think we can agree with him? We got 20, but now you're going to tell us it's 40 instead. Should we agree with that?
You get 40 because you have that, and then you have the 2 here. You divide it by this, but you multiply on this side and you had to divide on this side, so you divide this by that to get 20.
I think I know what they taught you, and you just kind of over time somehow mixed it up a little bit. Okay, but you got a good thing going here. But I am gonna have to fix it a little bit. Okay, thanks,
Yeah.
Cody. Okay, so I think what Cody's trying to do is this. We can rename 2 as 8 by multiplying by what? 4. If we took that 2 times 4, it would be 8, wouldn't it? So it's kind of like we're renaming this fraction. We're making it into 8s instead of halves. So if we take the denominator times 4, then we have to take the numerator times 4. 5 times 4 is 20. Maybe that's it, Cody? No, that wasn't it either. Okay, I tried. Okay, well, Cody, I'm going to have to tell you that what you're doing up here, we can't go with it, I don't think. I think we have to, we got to fix it still a little bit. There's something wrong with it, okay? Because the only solution to this one is 20. The only solution to this one is 20. Okay, anybody else think they know why we can think, first of all, without even, you just really don't want to work very hard, but you want to make sure you got a reasonable answer. Anybody else think they can tell me why 20 seems reasonable in this situation without, no, I don't want any calculating going on in that head of yours, okay? Seriously, just give it a rest. Tell me why 20 seems reasonable. Devontae?
Because 5 times 8 is 40, and if you replace the x with 20, 2 times 20 is 40.
Okay, that's exactly what Julia said, but guess what you just did? You did some calculating, and I don't want you guys to work that hard. I just want you to tell me if we think we can, at least say, oh, that seems reasonable. Cody?
We know that when you have a number times x and or a number that equals 2 times x, you always have to divide the number that's multiplying by x by that number to get your answer.
I know, here you are, you're wanting to calculate again, you're wanting to divide. Right, when I want you guys to show me work and calculate, you're like, why? And now when I say to you, don't, you're like, doing it. Okay, let me help you out here. Okay? Anybody, I'll give it, anybody think they still have the reason why we can say this is reasonable without doing any mathematical calculations? Go ahead, Cody.
Because x can equal anything.
Well, x can equal anything, that's right, and because we got something, we're happy. No, because it could be still wrong, right? Okay, and it still could be wrong, even this, what I'm going to talk to you about right now, but we still should be able to look at something and say, hey, wait a minute. You can't be happy with that answer. Noah?
What if we have 20 over x divided by 4 over 4 and get 5 over 2?
Okay, so if we put 20 over 8, is that what you? Okay, so if we put the 20 over 8 and said, and then what do you want to do?
Divide both the numerator and the denominator by 4.
Okay. So in other words, now we're going to rename this one. We're going to rename it as halves, and we get the same thing as was on the other side. Okay? Yeah. And you know, that's another good way to decide that, you know what, we have a good answer. But again, you're still working too hard for me. Okay. Compare the numerator in the first ratio to its denominator. Just, you know, compare them. What comparison can you make? 5 to 2. 5 is larger or smaller than 2? Larger. In the other ratio, what do you suppose has to be true with the relationship between the numerator and the denominator in that one?
The numerator has to be bigger.
The numerator better be larger also. Is 20 larger than 8?
Yes.
Okay, well right now, without having to really, you know, break my brain, all I have to do is look and say 5 is bigger than 2, 20 is bigger than 8. I'm feeling pretty good so far. Okay, that's reasonable. So again, I did no mathematical. Did we do any mathematical calculations there? No. Okay. What if our answer had ended up x equals 2? Should we have been happy to move on?
No.
No, we got a 5 over a 2, a bigger over a smaller, and we ended up with a smaller over a bigger. Should we have said, oh, got an answer, anything goes, I'm ready to move on?
No.
No. Okay. So, but we did come up with some other ways. You all came up with some other ways to check to see if you do have a good answer. And I was just asking you to make sure we had at least something reasonable. Okay? Yes, Cody?
If you reduce 20 over 8, you get a 5 over 2.
Yeah, and that's what Noah just did. He said if you divide both of them by 4, you get 5 over 2. And that's what should happen. One of the ratios should be able to be renamed to look exactly like the other ratio. It should be able to do that if you have a good proportion. Okay? Okay, who wants to give us the cross products for number 2? Number 2. What would the cross products look like? Noah?
4 times negative 3
4 times negative 3.
is equal to 1 times a.
Okay. That's the only way that one could have been done? Anybody think they know another setup we could have done and would be okay? What's another way we could have done that one? There's some more correct ways, and then there's some incorrect ways. Anybody want to take a chance on another correct way? Julia?
Negative 3 times 4 and 3 times 1.
Okay, negative 3 times 4 equals a times 1. Okay, how about another one? Noah?
8 times 1 equals 4 times negative 3.
A times 1 equals 4 times negative 3. So does it matter which side has the variable on it, in other words? No. Okay, so there are other correct ways to do this, but then there's also incorrect ways. Give me an incorrect way. Anybody come up with an incorrect way that'd be like, that's not going to get you to where you want to go? Cody, what do you think is an incorrect way?
Negative 3 times a equals 1 over 1 times 4.
Yeah, negative 3 times a numerator times its own denominator equals the other numerator times its own denominator. That's not cross products. Noah?
8 times 4 equals negative 3 times 1.
Yeah, a times 4, the denominators times each other equals negative 3 times 1, the numerators times each other. Is that going to help us? No, not going to work. So we have some incorrect ways to set it up, but we also have more than one correct way. Okay, go ahead and finish this one. See what you get. And then after you get your answer, decide, is my answer reasonable? Okay, why is your answer reasonable? Julia, why is your answer reasonable? By the way, did you say answer right? Okay.
Because the numerators are smaller than
Okay.
the denominators.
The numerator is smaller than the denominator over here, so it better end up, this numerator better be smaller than the denominator over there. And now when we say smaller, we have to be careful. We have to think about their distance has to be smaller, because in reality, negative 12 is smaller than negative 3. But we're just talking about its distance. Okay, can we come up with another reason why it's reasonable? I like that one, Julia. Noah?
When I got A equals negative 12, I took negative 3 over negative 12 and divided them both the numerator and denominator by negative 3 and we got 1/4.
Okay, so you took negative 3 over negative 12, you simplified it, you got it into a simplified fraction form, how it would show up in an answer bank, and it came out to 1/4. 1/4 matches 1/4. That's a good reason. Okay, anybody have another one? Did it have to end up negative? What if you ended up with it being positive? Should you have felt good about that? Come on.
Because our answer would have been different when we did the check.
Okay. And over here, what's the truth? What's true about the numerator and the denominator?
Positive.
They're both positive. What does a fraction bar mean? What operation goes on with the fraction bar? Division. Okay, when you divide a positive by a positive, what do you get?
Positive.
A positive. A positive divided by a positive.
Positive.
A positive. A negative divided by a negative.
Positive.
Positive. So it had to be turned out negative, didn't it? So that we'd end up with a positive fraction rather than a negative fraction. So there's different things you can use to help you decide, do I have a good answer or not? Okay, you try number 3 in your own and see what happens. Go ahead. Do number 3. When you're done, you can look up and see if you agree with me or you want to challenge me. Calvin?
Would negative 4.5 work?
Negative 4.5 would work, right here. I have it there. Anybody else? Okay. This one's a little bit trickier for deciding if you got a reasonable answer or not, isn't it? You really do have to kind of probably put it in, do some calculations. Probably wouldn't be a very easy mental math one. But what should be true when you do put negative 4.5 in? One thing that you should be able to say to yourself is, you know what? I do need it to be negative because I have a negative fraction over here. And there's nothing negative over here right now. I got to get it so that it is going to be negative. If I took it, if I ended up with a positive answer, a positive times a positive would be a positive, and then a positive divided by a positive would be a positive, and we'd be like, oh, that doesn't look good. You know those negative signs that are so easy to, say, oh, I just forgot to put it, or I meant to put it, or but in reality, we have to make sure that we are understanding why it should be negative or not negative. Okay? Anybody have any questions about that one? Okay. Then let's go ahead and work this last one and make sure that we are doing them. And I want you to do some, with this last one, after you're done working it, I want you to show some sort of a check problem showing that you have a reasonable answer, you're happy to move on, you will not circle the wrong answer in a multiple choice answer bank, because they know what kind of mistakes you're gonna make. It's amazing. How many 2.5s are there in 30? 12 of them. Number 2.5 is 2.5. Okay. How many of you are good with money? You can, don't have to have a calculator out when you're thinking about money. Okay. So 2.5 is the same as how much?
$2.50.
$2.50. Okay. Well, it's probably pretty hard to say to yourself, I wonder how many $2.50 there are in $30. That'd be a little challenging, wouldn't it? What would be easier to think, though? How many $2.50 are in? That's not. We decided that wasn't as easy. We want to break it down for ourselves. How many $2.50 are in 15? Okay, that's still a little less challenging. How about 10? Anybody happen to know how many $2.50 is? I don't even know if that makes sense to say it like that. There are in $10. 4. Without your calculator, Calvin? 4 of them. Oh, I thought you guys, somebody said you were good with money. $2.50. Okay, let's do it this way. How many $2.50 are there in $5? 2. How many times can you get $5 out of $30? 6 times. 6 times 2 is
12.
12. I'm trying to teach you guys to do some math without your calculators. And, so we don't have to be so calculator dependent, because I'm pretty sure that someday when they do autopsies on you guys, they're going to find mushy brains in the calculator, in the math portion, because you didn't have those muscles built up from not, all you could do is push buttons on a calculator. The autopsy report's going to read, they had a mushy brain part when it came to calculating numbers. They must have been calculator dependent. Okay, so you are now prepared, set to do your homework. Go ahead and take out your loose leaf and get started.